and we would do planetarium shows. And everyone was always so excited when it was about to be Orion season, because it was shows of whatever was in the sky that night. And so when Orion came up, it was like, oh yes, we can finally talk about all the things that are in Orion now. And then when we got into like fall and some of the more, you know, if we were back when Pegasus is coming up, it was a little bit more like, oh man, you have to, you have to go to the B-roll deep sky objects.
No, it's certainly award season, constellation wise.
Yes, for sure.
Coming up.
I will quickly mention before we get started, for those of you who are on Zoom, just make sure that if you want to talk to everybody, to change your little bar that says all panelists in the chat to all panelists and attendees, and then you'll be able to talk to everybody in the chat and not just us. We've seen lots of folks joining from all sorts of places, but only we can see it. So please do share, and it's nice to see where you're all coming from. And on that note, hey everyone, and a lot of us in Southern Ontario are experiencing some snow right now. On that note, Chris's background has changed to the appropriate, is it the appropriate constellation? Oh, nice. And so we're gonna jump in to Orion.
Hey, hi everybody. And we, as promised, let's do a quick preview of the Great Conjunction. I don't know if you've caught that in the media yet, but it caught me a bit by surprise when people started emailing me about the Great Conjunction. And I had to put two and two together and realize what they were talking about is Jupiter and Saturn meeting up. So let me just share my screen so we can demo what we're talking about here. And I'm just going to move Janet out of my way here for a second.
I didn't know that it was called the Great Conjunction for a while, and then I found there's a Wikipedia page on it. And so if it's on Wikipedia, it must be true, right?
All right, so you should be seeing the western sky, southern sky around 5 p.m. So now, during the past number of months, Jupiter has been dominating the sky because it's been sitting there nice and high in the southern sky, southern-western sky in the evening. But it's now sinking lower and lower into the west, because as the Earth goes around the sun, the entire content of the sky migrates sunward. So we lose things into the glow of the western post-sunset twilight. And so Jupiter and Saturn, which have been hanging out together all summer, are now getting into that zone, which means you might not notice them because they're actually getting low. So they might be hidden behind a tree or a building or something like that. But you definitely do want to find yourself a vantage point in your neighborhood where you can check out the southwestern sky after sunset and pick up Jupiter and Saturn. So what's going on is that they're both moving eastward prograde through the stars, but because Jupiter is so much closer than Saturn is, it actually travels to the stars at a faster rate, which means that with Jupiter now sitting a few degrees, and I'll just advance the time here a little bit. Let's make it a little bit darker. There we go. So with Jupiter sitting a little bit to the lower right of Saturn, that means it's to the celestial west. And they're both moving east, but Jupiter is moving faster. So that means that every night they both move this way, but Jupiter moves more. So eventually, towards the end of December, they're going to meet up, and then Jupiter will overtake and then start leaving Saturn behind. And so if I advance the time, let's see if I can advance. I'm going to advance by a sidereal day every day. So you can see here's December 2nd, 3rd, 4th, 5th, 6th, 7th. You can see them getting closer and closer. And if I put up a binoculars field of view, which you can do in markings, circular field of view, and I'll put that to 5 degrees. Let's see if I can get that to 5. Work. Yes, so that's about equal to 7 by 50 binoculars or something like that. You can see that they're going to sit nicely together in your binoculars. And once we get towards the middle of the month, they're getting close enough together that they'll actually start fitting together in the field of view of your eyepiece, your telescope. If you have a low power, low magnification, long focal length eyepiece, you can get them both to tuck into the same field of view. But they'll get closer and closer and closer, which means you can zoom in, zoom in, zoom in. And eventually, so what I'll do is I'm just going to advance the time here, get a little bit darker. Now, the disadvantages, though, is at the same time, you can see they're just sitting above the western horizon. That means that you're looking through a lot of Earth's atmosphere. So they're going to get a little bit blurry because of the Earth's atmosphere diffraction and jostling the image. So you're not going to get crisp views of them. But you know, you can certainly get your telescope out and take a good look. So here we are around mid-December. And I'll just advance the time a little bit. And I'm going to switch this from binoculars field of view. Oh, and by the way, at the same time, is you want to look for Messier 75. It's a little bit low. They're both sitting a little bit low in the sky for something as faint as Messier 75 to be very readily visible. But if you have a good sized telescope and you can center it sort of in the trio, you can get a sense of that globular cluster sitting there too. So let me just drop this down to about 2 degrees, which is common telescope refractor. So right after the mid-month, you can get them kind of all as a trio. Let's keep going. So let's see, alt equals. So they're actually drifting past because M75 is part of the background wallpaper, part of the stars in the background. So as Jupiter and Saturn migrate through the stars, they're also migrating through the deep sky objects as well. So that's why it'll leave those behind after mid-month. So here we go. By the time we get to around the 20th, then they're sitting nicely inside your eyepiece. And if you magnify to a nice high power eyepiece, you'll probably be able to see Jupiter, Jupiter's moons, Saturn's rings, maybe some of Saturn's moons. Now, again, they're low in the sky, so you might not get as much sharpness as we'd like, but it's spectacular. It hasn't happened since the time of Galileo. It won't happen again for another few hundred years. And it's definitely worth making the effort. But the one thing to remember is the media are going to be talking all about December 21st. But as I've just showed you, they'll be close together for a whole bunch of days, right? So you can start a week early and keep watching a week after, and you're still going to be fine. Go ahead, Jenna.
I was just going to mention, so Joe asked in the Q&A as well, and Ashi asked to clarify. So the last time that they were this close together was 1623, which is only 14 years after the invention of the telescope, which is pretty cool. But bear in mind that these conjunctions happen I think about every 19 or 20 years or so. It's just that they're not always this close. Jupiter takes 9 years, 12 years to orbit, and Saturn takes 30 or something like that.
Yeah.
And so it's whenever the two catch up, whenever Jupiter catches up to Saturn, that these conjunctions happen. So they do happen relatively frequent. They happen every 20 years or so, as in several times a lifetime. But it's been hundreds of years since they were this close together.
Yeah, and just to finish the thought, a conjunction is defined as the moment where the two objects share the same right ascension. So basically they pass each other in the east-west direction. So the true conjunction is not going to happen until around the 21st. So this is sort of the east-west line. So that's when the true conjunction on the astronomical officially term happens. But but it's called the Great Conjunction because they're just so close together. Now visually on that night, so wind this on back, they'll look like one dot perhaps in the sky to your naked eye. Your binoculars might be able to pull them apart, but because they're both going to be shining with a glow, with a bit of a halo around them, they'll sort of, the blobs will kind of merge together. So it'll be cool.
It'll be very cool. And the other thing I wanted to mention as well, it's one thing to see it in the Stellarium and look at that, and it's obvious, like that's really cool how close they are. Using our hand tricks to measure how far things are in space, if you extend your arm and lift up just your pinky finger, then this is 1 degree at a full arm's length for you. And these are going to be 1/10 of your finger width away from you.
Yeah, these are like a freckle.
It's like a freckle on the tip of your finger. Yeah, it's like a hangnail. So
yeah, just a fraction of your finger width. So this blue circle that I'm showing you right now, that's roughly 2 pinky fingers across. So these are so close together, they're basically a wrinkle on your finger apart. Mm-hmm. So it's really cool.
It's going to be really close together. And also a point for observing, just make sure that you can, see southwest nicely.
Yeah. Yeah. And the other thing is that, as I said, don't let the media scare you. You don't have to be out there just on the 21st. You can do it on the 20th, the 19th, the 18th. But every night, every subsequent night, they are going to drop lower and lower. So
Right.
start your attempt the week ahead rather than catch up on the week after, because they'll be getting lower.
Even if you don't have a telescope, it's actually just kind of fun to watch these two creep closer and closer together. I have not been observing. I've not been a good astronomer, quote unquote, this summer. I haven't been observing that much, but I've just been kind of keeping track of what's going on. And over the summer, you can of course see that Jupiter and Saturn are quite far from each other. And now when I look out my window, they're getting so much closer together. And it's just cool to see it progress like that. So I encourage you all, even if you don't plan on photographing them, even if you don't have a telescope, just take a look and watch them.
Yeah, so this is the sky tonight, just to remind everybody how they should look tonight. So around 5:45 or so, they're going to be sitting, what is that, about less than 2 fist diameters above the horizon towards the southwest. So that's where you want to look for them. So if you're not seeing them immediately, take a walk around, because there might be a building or a tree or something that's in your way. All right. So that's our preview of the Great Conjunction. Hopefully it turns out to be a great thing to get people looking up. But what we're here to talk about today is Orion.
Yay.
Go ahead.
I was just going to mention quickly that that Chris Baldock mentioned that the moon is going to be in a nice position, they believe, on the 16th and 17th to get a nice wide angle shot. And so if you're planning wide angle shots, give it a try sometime around the 15th to 17th with the moon in it too.
That's right. Yeah. All right. So Jen and I were talking before the stream about how everybody gets excited at this time of year with the arrival of Orion. Now, for the true diehard astronomers that have been staying up late at night, Orion's been up for quite a long time, because it was rising, just after midnight for a while there, and then it rises a little earlier. So this week we're still at the point where you need to be up a little bit later to see it nicely, but it does start rising in the east right around 7 p.m. and it won't really clear the horizon tonight, until after about 9 o'clock. And you want to look at objects when they're highest in the sky, because that's when you're looking through the least amount of Earth's atmosphere and you'll get the sharpest views of objects. And so just to sort of finish the thought here, if I pick the middle of Orion's belt, it's actually going to be highest in the sky around 1 o'clock in the morning this week. But every week it rises, it becomes more and more accessible, more available, rises earlier. And it's actually going to be available to view until about April. But, the best times are going to be kind of right after supper in sort of January timeframe. But it's never too early to start letting everybody know all the cool things to see in Orion. So that's what we're here to do today, is give you a kind of a winter preview. Here we are on the first day of December.
And who are we to say that you're not observing at 1 in the morning in the middle of winter?
That's right. You might.
If so, huge kudos, because that sounds miserable.
So, Orion is definitely worth bundling up and getting outside for. It's really great. It's got lots to give us for naked eye observing, for binocular observing, and for telescopes observing of every size. So, and that's mainly because it's tucked up close to the Milky Way, and so it's been populated or littered with a lot of cool deep sky objects for that reason. Now, Orion is one of the reasons Orion is so well known is because it's got the bright stars. It's arguably, we did our Out of This World record show, and we said that Orion was among the brightest constellations just because it has, on average, a brighter set of stars than many other constellations have. It's got a couple of the top 20 stars in it that make it extra bright. And of course, it's got a very distinctive, easy shape. The other cool thing about it is that it actually straddles the celestial equator. So if I draw the celestial equator on here, not that one, that one. So that means if you lived on the equator, Orion would be straight over your head. For us in Canada, then Orion sits in the southern half of the sky. But if you lived in the southern hemisphere, Orion is visible in the northern half of their sky. So it's visible worldwide, which means that it's been noted by cultures, ancient and modern, all around the world through antiquity. And what's cool about Stellarium is that you can go into the star lore and you can bring Orion up into view, and you can click through all the different cultures and see how the constellation changes its shape and is interpreted in different ways. So I'm just going to show you a few things to do with that. So first of all, in the Greek tradition, let me just bring up here. So here's Orion as sort of depicted classically. So he's shown as kneeling. He's got an upraised club in one arm, and he's got a lion's pelt or possibly a shield in his other arm, depending on the artist that drew it. He's, in this case, it looks like he's sort of fending off an attack from Taurus. And then his belt is down here, and then he's got this great sword that hangs down below. So that's the picture of Orion from that point of view. Let's go back here. Now, in Babylonia, they used to refer to Orion as the heavenly shepherd. And instead of him holding up a club, he was holding up a shepherd's crook. So they just connected the stars in a different way to make him look like a shepherd's crook. And you can do that in Stellarium if you pick the Babylonian constellations. The Egyptians actually combined Orion with the stars below him in Lepus, which is the rabbit. Let me just add the artwork here. There's Orion and the rabbit below him. And they made a larger constellation which represented their god Sa. And Sa was a deity that was associated with the deity that was connected to the star Sirius. And that's because actually Orion leads Sirius up, precedes Sirius in the sky. So Sirius was very important to the Egyptians. It was part of their calendar system. And so they connected Orion to that star as well. The Muslims called him Al-Jabbar, or the giant. The Polynesians actually saw him as a cat's cradle game, where you used the 4 bright stars in the corner and the belt in the middle, and you could make the string in the cat's cradle. The Maori incorporated Orion's belt and parts of the V of Taurus into their giant war canoe. So we talked about that giant constellation in our Insider's Guide session for the world records, out of this world records. That constellation was called Tawaka o Tamareti. That's cool to look at. Now, in Greek mythology, Orion was known as Prion. He was the son of Poseidon, the god of the sea. He was known for being a great hunter, and that caused a little controversy. So at one point, he boasted about hunting and killing all the animals on Earth. And Earth Mother Gaia didn't take well to that. So she sent the scorpion to sting and kill Orion. Thankfully, the healer Ophiuchus was standing by, so he actually gave Orion medicine to cure him. And now in the sky, you'll see that Orion and Scorpius are on opposite sides of the sky. So as Orion is setting, Scorpius is rising, and vice versa. And Ophiuchus is placed with his feet. His feet are on the top of the scorpion, stepping on him. So that's cool. Let's see. In the Bible, Orion is mentioned a few times, and you might have heard the name Menelvagor, the swordsman in the sky, from Lord of the Rings. So Tolkien put Orion in Lord of the Rings as using that name for him, Menelvagor, or something like that. Yeah. Now, the other cool thing is Indigenous people have also seen Orion. Now, it's too bad we didn't have an Indigenous storyteller for it with us here today, but if you go into the star lore and you switch, whoops, not this one, let's go to the star lore and switch to the Ojibwe. I'll just bring up, here we go. And so in Ojibwe, they called Orion the winter maker, obviously for obvious reasons, because he's bringing the winter months with him together. They actually envision the constellation with these long arms that are holding the stars Procyon and Aldebaran in the 2 hands. So it kind of makes him even more imposing in the sky. So let's go back to...
I will take this moment to mention that the drawings in Ojibwe are by Annette Lee and her team at Native Skywatchers, and I will send out that link in the chat and the Google or in the YouTube description as well.
Yeah, and if you want to look up, Annette and her collaborators have written a couple of nice small books on a couple of different Indigenous culture star lore, which are great. I own the Ojibwe.
Yeah, we sell it at the Rask store. So in case you are interested in buying it, it is online on Rask, rask.ca. And I will also mention as well briefly, because I can, and because we have you here, if you're interested in Indigenous astronomy, Annette and her team have been putting on webinars in conjunction with NASA for several different types or several different Indigenous groups. So she's already done Ojibwe and Lakota Dakota. And then on December 17th coming up, she's doing Mayan astronomy as well. And so for the list of those, I have included that after the first link. And she has experts from all the different communities, and they all go over just a ton of information about astronomy, and it's fantastic.
Yeah, and you get a lot of culture in those sessions too. It's really great. They have music and dance and all kinds of things. Okay, now let's get into what everybody recognizes Orion for, and that's his belt. So the 3 stars in Orion's belt form this distinctive asterism in the sky, these 3 stars almost in a line. You may have heard some people link Orion's belt to the pyramids of Giza. There's some claims that the pyramids of Giza were constructed and positioned to line up with Orion's belt or to match it. I'd say the jury's out on that, but it's an interesting thing to think about. Lots of different cultures have seen different interpretations of his belt. The Scandinavian countries have seen a distaff or a scythe or a sword. Catholic countries consider those 3 stars as 3 Marys in their gospel in the New Testament. The 3 kings or the Magi have been interpreted as those 3 stars. In China, they see those stars as something called the weighing beam, and the constellation for them is the 3 stars in Chinese.
I have a question just about the pyramids. Sorry, when you say talking about the belt of Orion, do you mean like the 3 pyramids are in a line the way that the belt is in a line?
Yeah, so 3 equally spaced pyramids, and perhaps with a little bit of a bend in the row.
Okay.
So
All right,
it is a bit reminiscent.
Okay, if there is a little bit of a bend, I can almost buy it, but otherwise it's like this is a line.
Yeah, it's the way that they show the argument is sometimes they need to flip the satellite imagery upside down to make it work. So
okay.
It depends on how you want to treat it, but
You never know.
possible.
A lot of different cultures have taken inspiration from the stars, so I wouldn't say it's totally out of the question.
Yeah, I mean it's great that people, and don't forget that you can also make up your own pictures. If you have your favorite way of seeing the stars, you can certainly do that yourself. One of the cool things is that if you happen to live in the Southern Hemisphere or visit there, is that they see Orion upside down. And let's see if I can just make it like this. I'm just going to take off the Orion picture here for a second. So here's the belt. And here's this sword, contains the Orion Nebula. And they see that, they colloquially call that the frying pan. So the 3 stars
cute.
at the bottom of the frying pan, and then the sword is the handle of the frying pan.
Huh.
And you can also try that experiment yourself by looking at them upside down sometime. See if you can pick that up. Now the 3 stars in the belt are Alnitak, Alnilam, and Mintaka. I'll go through them, what they mean in a minute or so here. To the first casual glance, they look the same, but actually, if you look at them, you'll notice that Alnitak is a bluer, whiter color than the other 2 because its spectral class is at that end of the range. Mintaka is actually considerably dimmer than the other pair. It's about almost a magnitude dimmer. But Alnilam is almost twice as far away as the other 2. So it's really funny. Actually, I've got a 3D model of Orion, which I can show you here. Because of course, when did that say? I can't open that.
There were several people early on in the live stream who were interested in a 3D model. So I'm sure they
let me
very
bring that
excited.
up. So obviously, when we look at constellations, we're just looking at a 3-dimensional universe painted on a celestial sphere. So let me just bring this up and show you this picture. All right. Hopefully this works. Here we go. There we go.
Oh, wow.
Yeah, so there's a graphic. Let me just bring that up again. Yeah, so from our perspective on Earth, we're seeing this pattern of stars that make Orion, but the distances of all the stars are different. So here's Betelgeuse, which is relatively close. So the shoulders of Orion are relatively near to the Earth. The feet of Orion are roughly the same distance, so they're down here. And then the belt stars are Alnitak, Alnilam, and Mintaka. You can see that the middle star is twice as far away as the other ones. And there's the Orion Nebula, so it's far away as well. So that's sort of a cool thing to look at. And you can do that with any constellation. You can get the 3D models, diagrams for them. It's really fun.
If you're looking for things to do with your kids, if you're bored at home, or if you are a human who is bored at home and wants something to do, you can make your own constellations by three-dimensional by using, depending on what you have in the house, beads or marshmallows or whatever you have, something that can hang, and set up a little, like a piece of netting on a stand, and you can hang the stars at different distances away to rebuild the picture, but have the stars be the right distances, relative distances from you as Earth.
And of course, the other corollary to that is that if you walk around, you can make the constellation shape change. And that means that when humans eventually travel the stars, the constellations will start changing shape as soon as we leave our neighborhood.
We did that at the GA in 2019. We rebuilt constellations inside of a big tent. And then you could walk through and change perspectives. Joanne asks if you know where you can get those 3D constellations. Chris, do you know is there like a resource or something like that?
I'm not sure if there's a specific source. I just basically Googled the term. So pick your constellation and do star distances or
Wikipedia has,
like that.
Yeah, Wikipedia has lists of the bright stars and how far away they are. It's not always presented in those pretty pictures, but you can kind of figure it out from there.
The STARWALK app, what's astronomy app, it actually has a mode where you can select a constellation and it'll do a 3D graphic of the rotating star set for each constellation. Cool. That's cool too.
STARWALK. I'll see if I can get the link for you all.
All right, so let's start sort of breaking this constellation down a little bit. So Alnitak is a double star. It's quite close. It's a blue supergiant. It's about 820 light years away from the Earth. It emits a lot of ultraviolet light, and it's got a very high surface temperature. It's about 31,000 kelvins. A Kelvin is, at that temperature, a Kelvin is basically equivalent to a degree Celsius, if you can think of. Our sun is about 6,200 Kelvin, so 31,000 versus 6,200, you can tell the star is a lot hotter. And the radiation from that star is actually energizing the hydrogen gas that's in space around it. So we'll come back to the cool deep sky objects that you can see. But if you look at Alnitak through a telescope, you can actually tell that it's double. I think I can make that. Yeah. So if I magnify that, you can see that it splits into two stars. So you can get a double star view in your telescope. Let's go back. The middle star is called Alnilam. That means string of pearls. By the way, Alnitak means girdle, by the way. Alnilam means string of pearls. It's another hot blue-white star. It's about twice as far away, as I said, as the other two. This one is actually aging, and it could become a red supergiant in the near future, astronomically speaking, near future. Sort of probably not tomorrow, but sometime in the near future. And that could become a supernova one day because it's a massive enough star for that. And obviously, if that supernova happened with the star being almost 2,000 light years away, we'd have to wait for that explosion to reach us. So that's kind of fun about astronomy. Mintaka is the western star. Its name comes from a Arabic phrase for belt. It's also a double star in a telescope, so you can zoom in on it and you can split it. You can split it into an easy double there, and you can keep going. And I think you can make another double star out of it if you magnify it a lot. Yeah, I have to change my star settings to make them split apart, but you can certainly do that with your telescope. All right. Now, Mintaka is actually part of an eclipsing binary system. So it has a star, one star orbiting, a smaller star orbiting a main star, and that can produce a variability and that kind of thing. So it's really cool. About 900 light years away. Now, when you're there looking at the belt, one last thing you can look for, I don't know if you can tell on the Stellarium here, but there's an S-shaped asterism. So a dot, 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 kind of in an S, curly S shape, sitting between Alnilam and Mintaka. So that asterism is cool to look at. All right, let's pull back. Let's look at some of the other bright stars. So we got Betelgeuse, everyone's favorite red giant star, Betelgeuse. So Betelgeuse's name. Go ahead.
We're so excited about that. It feels like years ago. I think it was probably maybe only a couple months ago. I have no idea when it got all dim.
Yeah, so it was about a year ago, almost exactly a year ago.
Oh, wow.
Betelgeuse has always been variable on a few different time scales. So it has a long period of variability, and it's got, you know, a shorter version of that, and so on. And so last winter, it suddenly dramatically decreased in brightness. Astronomers were shocked. They wondered whether it was getting ready to blow up in a supergiant, in a supernova, because it's an old red supergiant star. But my understanding is that after a further study, because it did actually recover its brightness in the spring and came back roughly to where it used to be. They think now that either all three variability periods synchronized, so it went dim for all three reasons, and that combined. But I think what the real consensus now is that an orbiting cloud of opaque dust temporarily passed in front of the star and dimmed it dramatically, and then moved off. So it was fun to speculate for a while whether we're going to see a supernova. If Betelgeuse ever does go supernova, it's about 600 light years away from us, so we would not be in any danger. We would just have front row seats to a fantastic show. So it would go really bright for a few days, probably visible even in the daytime. Then it would fade gradually over time, and eventually Orion would lose his shoulder because it would fade beyond visibility at some point.
I believe it was in Insider's Guide where we were talking about if you had been able to see, or if any stars had ever gone supernova while they were conjuncting with the sun. So in case anyone was curious, we did follow up with our resident historian, and he said that no cases of that have ever been documented, as it's also a relatively, like, it's an extremely rare occurrence as it is. And it would be hard to know for sure without having a really extensive knowledge of what was going on. So it would have had to have happened in like really recent times, I think. That was more or less his answer, right, Chris?
Yeah, so the idea there is that from the moment that a star goes supernova to the time it peaks and then fades to nothing can be as short as a couple of months. And that's roughly the time that stars become unobservable while they're passing the vicinity of the sun in the sky. So my ponderings was, could a star have gone supernova just as it was getting into the sun's glare, and then by the time it moved out, it's gone. But no one could come up with an example where that was known to have happened. So
we checked, but oh well. Now,
the name Betelgeuse comes from an Arabic expression. There's a few possible phrases that could be used, but one is Ibn al-Jawza, which is sort of Betelgeuse or Betelgeuse, and it means the armpit. So it's literally the armpit of Orion. Some phrases have it being Yad al-Jawza, which is the hand of Jawza. Jawza was the character they saw that was Orion. So they saw the person of Orion as this person Jawza. So it's his armpit or his hand, depending on the interpretation. In China, they call Betelgeuse San Su Si, which is the fourth star of the constellation of the three stars. Which is funny.
That's hilarious. That's a great name. That's like you almost made the list, but not quite.
As I said, it's about 500 light years away, 500 to 600 light years away. It's already swollen up because it's getting towards the end of its life cycle. If it were traded with our sun, it would be so big that the Mercury, Venus, and Earth would all be inside the star, maybe even Mars. That's how big it is compared to our sun. Let's see, I talked about how it got dim. All right, so let's go on to the next one. So Betelgeuse is among the top few brightest stars. Rigel is I think the brightest star in the constellation. Normally you can see up here it's shown as Beta Orionis. Normally the Alpha is the brightest and Beta is the second and Gamma is the third, but because of all these stars are varying in brightness a little bit over time, the order of these things sometimes gets a little bit incorrect. But so Rigel is also one of these hot bluish stars. It shines about the same brightness as Betelgeuse, but actually it's about twice as far away, much farther away than Betelgeuse is. So that means it's emitting a lot more light. It's very luminous. They call that high luminosity. It has a temperature of about 11,000 K. And if you have a really good telescope and good seeing conditions, you can spot a tiny little companion star tucked in close into the glare of Rigel. That's a little secondary star. Rigel from Arabic means the foot of the Great One. And in China, not to forget them, it's the seventh of the three stars. All right.
I like that.
Now,
it's very logical. It's a very logical naming system.
Sure. So up here we have Bellatrix. Bellatrix you'll know from the Harry Potter books. And by the way, the name Bellatrix obviously preceded J.K. Rowling's writing. So she took the name of the star and put it in her books as the character.
And a note that if you've read the books in it, or if you've seen that one specific scene in the movie where they have the family tree of the Black family, there are other characters named other astronomical things.
That's right. Other stars and things like that.
There's like Andromeda, I think, is in there. Anyway.
Yep. Bellatrix comes from a phrase that means the Amazon star, like the warrior women of ancient times. It's about 250 light years away. It's also a hot white star. You're seeing a pattern here of a lot of these stars being hot and white. That's one of the reasons why they're so dominant in the skies, because they're really pumping a lot of visible light out. Let's see what it's also aging as well. Bellatrix is aging as well. And again, these hot blue stars, they burn their fuel quickly, so they don't have as long lifespans as, say, a star like our sun. Now, up here above and between the two stars, we've got this star named Maesa. Maesa is actually a part of a cluster of stars. So if you grab your binoculars and zoom in on the star Maesa, you can see this clump of stars. Maesa translates from something called the Shining One. And its Bayer designation, or its Latin phrase, is Lambda Orionis. And the clump of stars around it is sometimes called the Lambda Orionis cluster. All right, now the last star we missed so far is the other bottom foot down here. That's Saiph or Saiph, I'm not sure the pronunciation. Another hot blue star, 26,000 degrees. It's also getting old. So there could come a time in the long future where all of these stars at Orion are going supernova. It's fun to think about. All right, so.
I am excited for a day when we can see a supernova in person.
Yeah, well, I'm of mixed minds. I don't want to ruin my favorite constellation, one of my favorite constellations, but yeah.
Maybe we can see one somewhere else, but no matter what, I'd like to see one in my lifetime, please, if the universe is listening.
Okay, we'll put that order in for you. All right, so now along his west, we've got this row of stars. It's about 6 or more stars. You can connect the dots to make the lion's pelt. Now, the funny thing is that the star in the middle, this bright one in the middle, is called Tabit. That means the endurer. But its other name is Pi. So this looks like an N, but it's actually the letter pi in Greek. Pi 3. And in fact, these stars are Pi 1, Pi 2, Pi 3, Pi 4, Pi 5, Pi 6. I don't know why they decided to name them all Pi. Normally, maybe they were worried about running out of Greek letters. So they decided to group them all together back in the day, but it's Pi 1 through Pi 6. And you can see that Stellarium's got some other alternative names that are used here, Altaj. I'm not sure what those mean. Over in the club is cool because if you start at Betelgeuse, pop up one star, then you can see a pair and another pair. It's quite a kind of a neat progression that you can watch, how the club upraises above his head. And there's lots of rich star clusters and things buried in here because it's coming on to the edge of the Milky Way. You can maybe see the Milky Way in Stellarium here is coming up along this edge. Now, Orion is cool because you can use them to point at other things. So we can look at the belt. We can extend the belt down, points roughly towards Sirius. So we can extend the belt up. It sort of points towards Aldebaran and Taurus. You can connect Rigel to Betelgeuse and get yourself to Castor and Pollux, the twins of Gemini. And I think, yeah, that's about the main ones. There might have been one more that I'm not sure. Now, this is where you want to get your binoculars out and your telescope out and start exploring the Sword of Orion. So the Sword of Orion is where all the cool stuff is. So if you look at Orion's sword, it looks like 3 patches of light, but the middle patch, if you magnify it, it becomes a fuzzy blob. And that's because it's the Orion Nebula. So it's called the Great Nebula, the Orion Nebula. We also call it Messier 42 after Charles Messier's list of deep sky objects, or M42 for short. And there's another sort of the nebula breaks into a couple of pieces. So you get Messier 42 and Messier 43 next to one another in the sky. Let's see what else. Okay. So then the Orion Nebula is one of the closest star forming regions to our solar system. So it's actually a stellar nursery. The reason it's glowing is because there are young hot stars recently formed that are blazing away inside the core of this gas cloud, emitting radiation and producing the glow of radiation. Now, when you see reds and pinks, well, basically red colors in nebulas, that's because the hydrogen gas they're composed of is being energized by the radiation of the star. It sort of emits the electrons in the outer shell of the hydrogen atom, and when the electrons relax, they give off a red photon of light, so you get that reddish color. At the same time, if you've got dust that's sort of mixed into the mix of the cloud, the dust will scatter the light from the star with a blue color. It's the same principle that gives us blue skies on Earth. It's the way that the blue is scattered compared to the other colors of the rainbow. So we call the reddish colored nebulas emission nebulas because they're emitting the red light. We call the blue nebulas reflection nebulas because it's the starlight reflected off the dust. And then, of course, if you mix blue and red, you get the pinks and purples. And so that's why the Orion Nebula is this mix of pinks and purples that you get in nice long exposure photographs. So it's about 1,400 light years away from the Earth. It's in sort of the neighboring arm of the Milky Way. So it's relatively, our next door neighbor in the galaxy, if you like. The nebula itself can be sort of measured to be about 4 full moons across. So it actually takes up a lot of the sky, but you need very, very dark sky conditions in order to sort of see it much bigger than we normally do. Inside the center of if you zoom in Stellarium, you can see that we get the stars in the core. There's this little clump of stars here that I'm just going to zoom in more and more and more. And they actually form this trapezoid shape. This is called the trapezium cluster. The 4 stars occupy the corners of a trapezoid shape. Any small backyard telescope should be able to see those 4 trapezoids type shape in the middle of the nebula. So you don't need a giant telescope to see that. The bigger telescope will give you more of the nebulosity around it, but the stars are very visible even in a small telescope. These stars are hot, O and B stars, again, like the other stars in the constellations. Their radiation is helping the nebula to glow. And one of the things that's cool, if you do a little research on the Orion Nebula itself and look for some of the high-res Hubble Space Telescope images of the nebula, is they've been able to find little baby solar systems in the process of forming, these little sort of brown, almost embryonic blobs where stars have got the dust collected around them and a protoplanetary disk is beginning to form. The trapezium or trapezium cluster has been known since the early 1600s. Messier, of course, saw it and noted it and Messier noted it in his list. Edmund Halley of Halley's Comet noted the nebula in his notes. In 1880, astronomer named Henry Draper from the Harvard Observatory, he took the first photograph of the Orion Nebula way back in 1880, which was amazing. It was the first deep sky photograph, deep sky object ever to be photographed. So what you can expect to see in a backyard telescope, you won't see the colors because you don't get enough photons delivered to your color receptors in your eye, but you'll get ghostly blacks, whites, grays. And one of the things that I noticed the last time I looked at the Orion Nebula was it looked like almost a Klingon bird of prey with the arms outstretched, or maybe a seagull sort of drifting in the breeze. So you can see these sort of brighter arcs that'll be picked up mostly in a small telescope. So take a look at that. Sketch it if you can. Lots of people have a lot of fun. Get some black construction paper and some white pencil crayon maybe, and try it that way, or try, or you could try doing a photograph of it. It's a little bit tricky to get a photo of a nebula, but you could sort of give it a go.
If you're going to try to get a photo of any nebula, this is a good one to get because it's so bright.
Yeah. Yeah, so as I said, there's a sort of a separate lobe of the Orion Nebula on the side of it. So Messier gave it its own number in his list. And that one's surrounding the star here. It's called Nu Orionis, N-U Orionis. Okay. Now, the fun's not over. So you can go below the cluster and you can see this. The stars here are enveloped in this bluish reflection nebula, which you can certainly pick up in long exposure photographs. So these this group of stars is called Nair al-Saif, or the bright one of the sword. Again, it's another hot star that's probably going to become a supernova one day. And astronomers think that this particular star might have been ejected out of the Hyades cluster. That's the cluster that's the V-shaped stars that form Taurus. So that's cool. And you can go a little bit further along. So it's fun to sort of swoop along. There's a star down here called Thabit. I think it's this one, the Orionis, the Endurer. Oh, there's Thabit. Yeah, there's Thabit is the Endurer. So then you can go back to the Orion Nebula and start heading up towards the belt. So the first thing you're going to come to is this reflection nebula, this fuzzy patch. So this is called the Running Man. So in a certain photographs, there's some darker dust that's obscuring the gas behind it, and it almost looks like arms and legs and a person sort of running in that group. All right, now there's another group of stars here. This group of stars is called the Kolkar cluster. That's a good one for binoculars. And then if you start sweeping up towards the belt, before you get to the belt, you want to stop at this star. This is a naked eye star. So if you're seeing Orion in the night sky, find the belt and look to the lower right a little bit, and you'll pick up this star. And if you zoom in on it, it's one of the coolest star clusters to see in your telescope because it breaks into this really sharp V of stars. You get 1, 2, 3, 4, 5. So it's really neat. It's like a wedge, almost like an arrowhead of star. This is called Sigma Orionis. So it's a really cool tree. It's sort of considered a double, but it's really a multiple star system. So it's really a neat one.
There was a question which doesn't have context in the chat, and I think it's to do with the star that you mentioned that they think was ejected from the group in Taurus.
Mm-hmm.
How would they know something like that? Just based on the age of the star or the color or the composition?
Yeah, that's a really great question. So when astronomers study star clusters, what they're doing is they're taking detailed analysis of the starlight coming from each star in the group, and they can tell from the spectrum that the stars have all shared composition and age, and so they know that they're siblings. So you can look for interlopers or stars that maybe don't belong like the others. And in this particular case, the spectrum of that star matches the spectra of the stars in the Hyades cluster. The other thing they can do is they look at the way the star is moving through the galaxy. So if a star has a proper motion that's carrying it across the sky, they can extrapolate back along that vector and see perhaps where the star originated. So there's sort of a combination of different things that they can use, pieces of evidence.
Cool. Thank you.
Yeah. So let's get into some other deep sky objects that you can check out, especially if you do have an astrophotography rig, or if you've got a small star tracker that you can put a camera on with a nice long focal length lens. You can start picking up some of these objects. So the star Alnitak, which is the left hand or eastern star of Orion's belt, he's got some really cool objects tucked in beside him. One is this emission nebula, and this is the famous Horsehead Nebula. Now, it's not really visible visually. It's the sort of thing you pick up in a long exposure photograph. But what's happening here is that you've got radiation from Alnitak is energizing the gas. And then you've got a patch of dust in the foreground that's just blocking the light from the red light from behind it in the shape of a horse's head or a seahorse or a chess piece, whatever you like. But it's I remember this object just fascinated me as a kid. So it's I remember seeing this one as a kid and just thinking, holy cow, that was great. I just love that one.
It is very cool. It's amazing what can seem, yeah, it's just so cool to see objects that look like the things that we recognize so clearly. Like when you mentioned the Running Man, I was like, yeah, okay, I didn't really see it, but this, you cannot mistake it.
Yeah. Go and look up, when you have a chance, look up an infrared image of the horse head. And in that case, they've actually almost created a 3D model of the gas that's producing that silhouette.
Oh, wow.
So it's more like almost like a willow tree, like something with a trunk and then some drooping sides to it. Anyway, it's really, really fascinating.
For some reason, Wayfair has a lot of them for sale.
Is that right?
Yeah. It's a Hubble image though, so it's out there if you want to take a look at it.
Now, again, you can see a number of these bright stars have the blue reflection nebulas, the blue halos around them. Again, Alnitak is pumping its energy into this other gas cloud. This is called the Flame Nebula. It has different names. If you actually click on it in Stellarium, it comes up with alternate names for it. Let me just bring it back here and click on it. Let's see if I can do that. There we go. So Stellarium's got Flame Nebula, Tank Tracks Nebula, Maple Leaf Nebula, Lips, Burning Bush, Ghost of Alnitak. But basically, again, you've got radiation causing the gas to glow, and then you've got a lot more dust sort of interfering with or blocking the glow and producing these sort of whimsical shapes that you can see. So I can definitely get the idea of the maple leaf and the burning bush idea from this one as well.
Yeah.
This one's a bit brighter, so you might have better luck seeing this visually through a good telescope on a dark night, but you want to tuck Alnitak outside your eyepiece's field of view a little bit, because it's so bright that it'll overwhelm the glow of the nebula beside it. All right. Now, a little bit further afield in the neighborhood, so you can keep going. Remember, this is the belt. By the way, Orion is a really cool constellation for seeing the effects of the diurnal rotation of the sky. So when Orion rises, his head is tilted to the east. All right. So let me just actually center on the belt here. So when Orion first rises, he's tipped leaning to the east like that. By the time he gets over the southern horizon, he's upright. And then by the time he sets in the west, he's leaning the other way. And that's all to do with the way the Earth rotates. So it's not the constellations themselves flipping around, it's just our point of view on Earth. So coming back to our neighborhood here. So we've got, remember the horse head and the flame. Then if you head on up about, let's see how far this is. This is about only 2 finger widths. So it's not very far at all. to the upper left of Alden Attack, there's another one of these bright reflection nebulas. I'm just going to bring on the Stellarium images, Stellarium symbols. This has sort of got 3 lobes of a reflection nebula. One of them is called the Casper, the Friendly Ghost Nebula.
Aww.
That's fun to look at. Let's see, there's another one up here.
Does it look like Casper? Or is
I
it
don't
just,
know.
who
You
knows?
know, it's hard to say. Let's see. And way up at the top by the club. So when you get up near the club, you can look for these pair of stars. They're only separated by about, again, about 2 finger widths. So it's fairly distinctive star pattern. And just to the lower left of them, there's another one of these combinations of the blue scattered light and some stars embedded in the side. This one's called the Monkey Head Nebula, or NGC 2175. Now, you may have picked up on this idea that there are all these glowing nebulas around Orion. And actually, the really cool thing is that the constellation itself is just loaded with this gas. And if you take a long exposure photograph, let me see if I can bring up this picture of Orion here, of a long exposure photograph. Oh, all right, we'll go back to my library of images. Go here, and
I have one in a PowerPoint somewhere if you need me to go get it.
oh, I got it here.
Okay. Oh, wow. Yours is way
Wasn't
better
this
than mine.
amazing?
Yeah.
So there's Orion's belt in the middle. There's Betelgeuse, the orange one. Rigel is the other foot, Bellatrix, and Safe. And you can see that here's Mesa, his head, and there's a giant spherical cloud of gas all around it. And so that cloud of gas is the source for the Lambda Orionis star cluster, the Mesa star cluster. So that cloud collapsing is producing those stars. And then this big arc is called Barnard's Loop. And now that you've seen it, if you keep an eye out for it, if you look in galleries of people's long exposure photographs of the whole constellation, you can see that faint loop all around. And what's happened is that the stars that have been born in the core of the constellation out of that hydrogen, once they start shining, their solar wind, if you like, their radiation pushes the gas away and clears the gas from around them and produces a large bubble.
Huh.
So you're actually producing this huge spherical bubble with the shock, sort of the shock front being where the gas is collecting as it's growing. So that's the reason why Orion is so rich. It's got this incredible population of gas and dust that gives it all of those great blue reflection nebulas and red emission nebulas. So I think I've talked enough. I think we can take some questions.
Everyone's been sitting quietly enthralled, as I have as well. So if you have questions, please send them in now. I find that to be amazing. Would you have to modify the camera that took that photo?
Yes. So most terrestrial, consumer cameras are designed to filter out infrared light, some infrared light, because they don't want the heat, the sun's heat, altering the color tone of your subject. So they tend to have an infrared filter that cuts the infrared to let the visible light through. Whereas you need that light to be able to get to your sensor in your camera to get that nice rich red. So you can get away with that by shooting in black and white through a filter designed to capture that light. Or some people even modify their DSLRs. They get them sent away and have the layer of filter pulled off the sensor, cleaned off the sensor to allow them to get the red from the various nebulas. So
cool. I heard about that before.
That's where you want to do that to your second camera.
Yeah, I've heard that my brother was like, you should do that to your camera. I'm like, I only have one. Like,
yeah, Nikon camera, Sony, I think a number of the vendors are starting to sell astrophotography systems now where they've done that for you. So
and that's always nice because then no risks
taken. And you can use your lenses, right?
Yeah. Yeah, that's true. If you go with the brand of the lenses that you already have, then you can just use all the same lenses that you had for your regular camera with your Astro modified camera.
So let me just talk a minute about using Stellarium to explore a constellation like Orion. So what I've got, you can see that I have a little button here that lets me switch on and off the symbols for the deep sky objects and their names. If you go into hit F4 and go into the control for and tab over into deep sky objects, the DSO, you can dial up and down how many Stellarium shows you, but you can also use a setting here called proportional hints. And that'll make the symbol big if it's an easier thing to see. So that's why I've got a big circle around the Orion Nebula and smaller circles, the same symbol, but smaller around other objects that aren't as easy to see. And so if you switch that, by default, that's off. So if I turn it off, then everything's got the same size symbol. So if you really want to get a good sense for using Stellarium, but what are my best odds of seeing an object? You can flip that on and it'll sort of make them bigger for you.
We have a question about Barnard's Loop. Do you know how many light years it spans?
Off the top of my head, no, but I can find out in a second. Let's see here.
I'm doing a quick Google as well.
I think it's pretty big.
Wow, yeah. I've got Wikipedia saying either 518 light years or
well, that's its distance from us, but it's radius.
Okay.
Oh yeah, its radius is 50 to 150 light years in diameter.
Cool.
Yeah.
So I don't know
So
why it feels bigger than that. Oh yeah, there it is. Yeah, radius. Okay, cool.
yeah, and if you do go to Wikipedia, it has a really nice picture of it.
It does.
One tip, if you're ever looking for the best view of an object that you're fascinated by, is to put the name of the object in Google and then add APOD, which is the astronomical picture of the day. And that's where NASA posts the best of.
And it's often like non-NASA contributors. Like I know people who have gotten APOD spots before with their astrophotography work. And so you do get quite a variety of stuff, and it's very cool. And many astrophotographers aspire to APOD slots.
That's right.
I wanted to mention this early on in the show, but then the moment passed. But I wanted to mention that this is a really great constellation for beginners and or kids as well, because it's a winter constellation. Once we get to January, the night it's dark at like 4 or 4:45 or 5 o'clock. You can go out after dinner, as Chris mentioned, and go and see this. It's cold, yeah, but it means that your kids aren't staying up until 11 p.m. just to be able to see a constellation. So it's a really nice.
And what I love about it is that you can see the Orion Nebula just with binoculars. Yeah. You can already tell it's a nebula. You don't have to even own a telescope to start seeing a deep sky object. It's amazing.
And if you look carefully, you can actually, and you're in a dark enough spot, you can see it with your naked eye. And I swear I've seen it not nicely, but it's still there. You can see it with your naked eye in Toronto if you look carefully and from the right location with no bright lights pointing in your eyes. I have seen it near Riverdale Park, which is pretty cool.
Let me show another cool thing while we're here. We have a couple minutes left, I guess. Yeah, we have a couple minutes left.
Yeah.
I'll talk to you about the winter football. Let me get rid of.
Oh yeah.
So once we get into the winter months, and all these winter constellations are up in the sky, if you connect Sirius to Rigel, to Aldebaran, oops, let me just go down here, up to Capella, these are all super bright stars, down to Pollux, down to Procyon, and back to Sirius, it makes a giant football or hexagon shape in the sky. You can see it here. And there's the winter Milky Way running right through the middle of that big hexagon. So it's actually high in the sky around Super Bowl season. So some people call it the winter football, some people call it the winter hexagon. And the moon will pass through it every month. So the moon will jump through there for a couple of days every month. The other thing you can do is if you start at Sirius, Rigel, and dip in to get to Betelgeuse instead, you can make a giant G. cutting instead of finishing the oval shape.
So there's a large Google logo in the sky.
So this time of year, you need to be up around midnight to see that, but let me just see, a month from now, you'll be able to get that, you know, even 8 o'clock. It's above the horizon in January at 8 o'clock. So it gets easier and easier.
There are a couple questions. We get these a lot, and I try not to answer them because they're not particularly interesting, unfortunately, to a lot of people. But I do know that there's something that Chris can do to help you with this. There are a lot of like, can I see X with this setup? Can I see whatever object with my setup? Chris, would you mind going over again how to set up your own gear in Stellarium? Because Stellarium lets you choose your telescope and your eyepiece so that you can see exactly what you would see with your own setup. Of course, depending on sky conditions. So it does, like if you're in the city and you're trying to look for like, I don't know, something.
Yeah, we're not talking about what's achievable dimness wise. We're talking about what circle in the sky will you see. Yeah, and how big things look. So if you go down to F2, which is the configuration, and go on over to the plugins, there's a long list of things you can plug into your Stellarium. One of them is called Oculars. So if you go to Oculars and click Configure, and I know it seems a little bit daunting here, but you can actually click into eyepieces and you can look through the list and see if you own any of these eyepieces and add them to your collection. Or if you don't, you know, maybe you've got a Nagler, but it's not 31, you can put it here and you can change it. So you can change the numbers and save it and add it to your list. So Stellarium will know, because you've added it to the list down here, that it's one of your eyepieces. And then you can go over to telescopes and you can put in your telescope details. So maybe you've got, let's see, here's a Celestron Schmidt-Cassegrain C8. That's a common telescope for sort of advanced beginners. Or you might have a 5 or a 6 inch. But anyway, if you've got to say a 6 inch, you could change the millimeters, focal length, and so on. You can add it to. So once you've got your telescope in the view, I don't know if mine's in here. A lot of people have an 80 millimeter. Here's an 80 millimeter. Yeah. Anyway, you can sort of play with it. Here's the Celestron Onyx 80 is a common telescope. So you could, if you have cameras, you can put, or you can add Barlows if you want to use a Barlow. If you have a camera, you can put the sensor in, the different cameras, Nikon, Canon, and so on. Once you've done that, then you can go here and you can ask under General to show the field of view. Let's see, where is my glasses on to see it. You can have a control, on-screen control panel. So there you go.
Oh,
so
nice.
Let's close this up. So then when you've got this control panel up here, so let's say we want to pick up the Orion Nebula. So we do this, and then we ask to view it through our telescope. So we can say, which telescope do I want? I want to pick whatever. You can go through that. You can scroll through the different telescopes, scroll through the different eyepieces, and it'll match up what you see through the telescope. So this is a, what have I got here? Here's an 8-inch, typical 8-inch SCT, and go to a, I can do binoculars. There's the binocular view. So I know that's a little rushed, but if you sort of play with it, if you mess anything up, just don't forget, you can always just shut Stellarium down and it'll come up fresh and you won't have ruined anything.
Yes, and we will, what I'll likely do, I've noted down the time that we've talked about this, and I'll probably just chop this section out and save it as a separate video so that we can link to it, because we get this question a lot of like, can I see X with Y? And so this whole stream will be available on YouTube afterwards, but that little section we'll probably put up on YouTube separately as well.
Yeah, so for example, I've got 7x50 binoculars showing right now. So I'm going to go to that Mesa, that's the head of Orion, and it'll just go there for you. And you can see how the cluster will look. So you could pick any object you want that we've talked about and get a preview of how it will look in your binoculars.
Yay.
There you go. Let me just stop sharing here.
And I think that's more or less it that we have for questions. And I know we're a little bit early, but we have thoroughly covered everything that's in Orion. I can tell you that for sure.
Yeah, I mean, obviously we're looking at our 2021 season where I'm happy to continue doing these. So if people have topics they are interested in having us talk about, let's hear from people and give some suggestions.
Yes, maybe I'll send out another survey. We will see. And then we'll see you all on the 15th, and then we'll see you again on in January after the holidays for more astronomy things. Yay.
Yeah. So we've got the full moon coming up, or just past the full moon. Yeah, we just passed the full moon on Monday morning. So by this weekend, the evening sky will be nice and dark again. So if you have clear skies, head on out.
Take a look.
Start enjoying.
There was a quick request for solar viewing. We may try that someday. The trickiest part is the clouds.
Yeah, so I have enough material that I could talk in general about the sun, and I can show you some techniques, but you know, we don't know if the day of we're going to be able to do views or not. I will say there is a large sunspot right now that if you have eclipse glasses, so put the eclipse glasses over your distance glasses, right? So you can see it far away, and you should be able to see the spot.
And just to be clear, when Chris says put them over your distance glasses, that does not mean put them over your binoculars. Do not do that. Only with your eyeballs, please.
Yeah, the best practice for eclipse glasses is you look away from the sun, you completely cover your eyes, then you look at the sun. When you're finished looking, you look away before you remove them. That's the way we do it.
Take a look, and then we'll see what we can get together for the new year. We will see you all in 2 weeks, and when we will be talking about binoculars, hopefully. We'll see you all then. Thank you, Chris, for telling us all about Orion.
Thanks for everybody.